In this lecture, we are going to look at the practical L6, which is the determination of the focal length of a convex lens using the displacement method. Now, in that experiment, you already know the procedure that you took in order for you to arrive at your values. Now, you are given the focal length, the approximate focal length for this particular person. Now, like I always say, for every practical, you should try as much as possible to use your values. Don't go and copy any other person's value. Is that okay? So for this person, the approximate focal length was around 13.5 centimeter. Now, the distance D was measured as 100 centimeter for this person. All right. Then we are now going to complete our table. Now the table, you have the first reading, the second reading. Now I saw some of your table and the values of the first reading are smaller than the values of the second reading. It ought not to be so. The values of the first reading ought to be higher than the values of the second reading. Is that okay? So you had your first reading, then the second reading, and then you have the displacement value, which is D, and then we have the separation. Separation is small letter d. Is that okay? Now this small letter d, what do you think we are going to do with it? We have another arithmetic here, which is d squared minus d squared. That is, you square this d, and then solve for their differences. So in order for you to get this column here, you look at this column. Let's take the first one for instance. This becomes 100 square minus, what do we have here? You have 12.5 square. Are you getting it? Whatever value it gives to you is this value you have here. Now for the second one, it's still the same approach. You have 90 square and then 9 square. When you subtract them, whatever value it gives to you is what you have here. The third, this 80 square minus 14 square. Whatever value it gives to you is what you have here. Is that understood? So that is that for this particular how to fill in your table. Now, having filled the table, the next thing is you should plot a graph of d square minus d square versus d. That is a graph of this column which I brought out against this displacement value. Now you know that for each of the practical, this displacement value is constant. Right? For each of the practical, what you were moving was the position of the lens, which was P1 and P2. And the differences between P1 and P2 is what was given as what? This small letter d. Understood? Exactly. So we are to plot a graph of d square minus d square versus d. So this is what you have here. Now, in order for us to plot this graph, alright, so we have this particular one here, and we are to plot a graph of d square minus d square against d. You know, when you are plotting your graph, the first thing is to choose, first of all, let us rule our line. So I'm going to rule our line here. How do I get to the line 2? Okay, I thought that is supposed to work here. Okay, let me exit full screen first. Abby, stop presenting first, not full screen. Okay, and then come to pen. These are our lines. All right, so let me rule the line. Can rule it from here. Sorry about this one. Can start ruling the line from somewhere around here up to this point. All right, and then rule another one from here up to this point. Is that okay? and then we can now start. This is actually pen. Okay, it's all right. All right. So we can label our graph. We say a graph. Okay. All right. Let me increase the size. I think we can now come back to presentation mode. A graph. Sorry. A graph of d square minus d square against d square here. All right. Now that you've written that, let us choose a suitable scale. Now, if you look at this axis, you can easily go, let one of this one be equals to 10 units. All right. So if one of the, 1000 units. If one of this one is 1000 units, here we start at what? 0, 0. Love the color of the pen to be red. So here will be 1000. Here will be 2000. Here will be 3000. Here will be 4000, 5000, 6000, 7000, 8000, 9000, 10,000. And then you have 1002 and upward. So we can say scale, for the scale, let 1 centimeter be 1000 units on d square minus d axis. That is this axis here. This is the y axis, which is what? D square minus d square axis. And then same way, let 1 centimeter be 10 units on the axis. So which of them is the d axis? The d axis is this axis here. So we are going to come here and label this d axis. So here will be 10, 20, 30, 40, 50, 60, 70, 80, 90, and then here we have 100. All right, so let us start plotting our graph. Now, for the first value you have here is 50. The value there is 2389. So we have 50 here. This is 2000. So we have 2389, which is almost 2004. So it will be somewhere around here. Let's mark this point. You already have your this thing now. You should know how to plot graph by now. Now the next one is 60. 60 value is 3551, which is, this is 35. So let's take it in between 3000 and 4000. The next one is 70. 70 is 4700 and very close to 5000. So we can take it at this point here. The other one is 80, 6200. So we have 80, yes, 6200, which is somewhere around here. The other one is 90, 8000. So we have 90 and 8000, which is somewhere around here. The other one is 100, 9800, which is almost close to 10,000. So we have 9800. So we need to draw our line of best fit. It's giving a curvish line like this if you go, but you have to draw a straight line because this graph is the graph of a straight line. All right. So let me stop presenting first so that I can get that option to rule. All right. So let's rule. If we take a straight line, It's going to be from somewhere around here, passing through. It didn't pass through much point. Okay, we can always, this is for this person's particular one. No, I didn't say all of them must follow this pattern. All right, how do I edit this now? All right, so it actually passed through these points like this. You can decide to take it this way. These are the points it passed through. Let's take it through here. This is the line of best fit. All right, exactly. By so doing, you'll be able to calculate your vertical scatter for this particular graph. So what we are now going to do is to take our slope. Now the slope can be any of two values from here. All right, so what I'm going to do, I'll just take the slope. You guys already know how to plot graph and take slope. So let me take this value and then this value, and then we are going to trace them down. So if we trace them down, it's going to give us broken lines. Are there broken lines here? There's no broken line here, so let me just use this one to trace it down. Can this one be edited? So this one is here. This one is somewhere around here. This one is somewhere around here. You know this is supposed to be broken line, so all right. Command Z. Remove that. Supposed to be broken lines. So this is how our this thing is going to be like. Now let us find the slope of this graph. That is the next step. They ask us what is the gradient of this particular graph. Now my dear student, if you want to find gradient, what did we say? Okay, get out. That is not what I wanted. All right. So if you want to find the gradient of this graph, firstly, what is gradient? Gradient is slope. Slope is gradient. So you can say gradient. All right. The gradient is what? Change in y over change in s, which is still the same thing as change in d square minus d square all over change in d. All right. So in this particular graph now, what do you think our gradient will be? Let's take this value here. This value here will be like 9,100, right? It will be like 9,100. So we have 9,100 minus this value down here is already 1,000, which of course we've seen here. So here is 1,000 divided by change in d. This value here will be 100. So we have 100 minus this value here would be this value here will be what value? This is 40. Here will be like this 40. Here will be like 40, 44. So here will be 44 also, right? Because the middle is 45. So we say minus 44. Oh yeah, now do this calculation and tell me the answer you are going to get. If you do this calculation, you are going to get the following answer. So here is 9,100 minus, okay, let me put it at once. 9,100 minus 1,000 divided by 100 minus 44, which gave us 144 centimeter. So this is our gradient. All right. So we can say our gradient, which is still the same thing as the slope, is 144 centimeter. All right. Now the next step now is show the gradient of the graph is related to the focal length of the graph. Now we are going to do some manipulation here, some mathematical manipulation. So everybody should pay attention. Now, what are those mathematical manipulations we want to do? It's a very, very simple thing. Now, how many of you will agree with me that we have what is it called? Now, there's something I want us to take note of here. You know the psycho theorem, the mirror formula we were taught in secondary school. We are taught that 1 over f, let me use this. We are taught that 1 over f is equals to 1 over v minus 1 over u. All right? That was what we were taught with the mirror formula. Where you were also taught that your f is the focal length. That is what we are looking for. Our v is the image distance. V is image distance. And then your u is the object distance. Now we are going to do some calculations here, manipulative calculations. So just be careful and take note. Now, the object distance, this here is the object O. Here is the screen. That is where the image is formed. You can see this inverted image here is the image we are looking for. All right, so this is the image. This is the what? Object. Now, the distance from the object to the lens is the object distance. Now, in this case, you agree with me that the object distance, you will always take it from the lens to where the object is. So, from the lens to where the object is somewhere like from here towards this direction. And in the number line, when something is going towards this direction, what do you call it? You say this is what? Negative value. So, this object distance will be negative u. Then, from the lens to the image is the image distance. Now, the image distance will be from here to somewhere around here, and this is our what? Our v. So here is negative u, here is our v. Now, for this particular practical, what did you guys do? This is a lens. The object is stationary, the screen is stationary. However, you move the lens from one position to another. The first position is what you call P1. The second position is what we call P2. Is that okay? So if you move it, first, it may be here, you are moving it towards the object, or from the object towards the screen. I understood that for this particular practical, it was from the screen. First of all, you place it close to the screen, and then you start moving it back towards the word object. But I'm going to use the case of object moving towards the screen to explain to you. It's still the same thing. You are going to have the same thing perfectly. Now, I actually just want to give you guys the formula before. However, I discovered that the question says show the gradient of the graph is related to the focal length of the lens. So you have to show. So you guys will write. Are you getting it? There will be a lot of things for you to write here. So just be focused, pick your pen, and then listen attentively. Some of you might not really understand it, but if you can write, you can just write and ensure you get the last formula. So like I said, this is the object distance, this is the image distance. All right, object distance, image distance. How about in a situation where you now move the object to this place? Now listen, before you form a screen, before you form an image on two different positions, the distance from here to here, which is the object distance u, must be equal to the distance from here to here. Are you getting it? Which is another object distance, what? U. Is that okay? Do you understand what I just said? I said that image can be formed in two places on a lens. Are you getting it? But what we are not trying to tell you is that the two places where the images will be formed, the distance between those two places, between the first position must the distance of the object to the first position must be equal to the distance of the image to the second position. What we are trying to tell you is that the object distance here must be equal to the image distance here. Is that okay? The object distance here must be equal to the image distance here. Now, in the same way, this V here must be equal to this V here. However, there's something I want us to do. That's why I said this is manipulative. This particular this thing is manipulative. Now, if here is U, now what is the distance between the two lengths? Because the distance between the two lengths is our D you are looking for. You understand? The distance between the two lengths is the D you are looking for. So how do you get that D? Now, this is, if you measure it, this is the second length. And this is the first length. The distance between this first and the second length, that is this distance between this and this, is our D. Are you getting it? Which is the distance of separation between the lenses. Now, why is it manipulative? Listen, you already said this is your U, because I said that the distance between the object to the lens must be equal to the second position between the lens and the what image that will be formed. All right. Now, do you know that from here to here is our D? Now, in the same vein, we also said earlier that from this position, from here to there, which is these two places we marked here, is our D. Are you getting it? Now, do you know that from this position to this position to this image here is still our V? Because we said that from here to here initially was V. Are you getting it? It also means that from here, let me use red, another color to code it. Let me use another different color entirely. So we can also say that if from here to here is V, it means also that from here to this position, like from here like this, sorry about that, to this position is also V. All right? Exactly. If from here to here is V, it means from here to here is V. But we said this is U. Are you getting it? This is your what? Your U. Right? This whole place here is V. Y here is our what? D. This from here to this position, that is from the image, the object to the image, is our big D. Are you getting it? From here to here is our big D. Now let us do the arithmetic. That's why I said it's manipulative, but you have to listen. Some of you may not understand it because you don't understand a lens formula yet. You are supposed to be taught this topic before they give you this practical anyway. So can we say, I've already said that from the image, the object distance to the image distance is our capital letter D. From this lens to the object is our U. From this object lens to the image is our V, image distance, object distance. Now, do you agree with me that D, which is this big D, is the same thing as what? U plus V. Do you agree with that one? That D is equals to U plus V? Exactly. Is the same thing. Are you getting it? Now, do you also agree with me that your D plus U is equals to this V here? Because we say from here to here is V. From here to here is D. While from here to here is U. So we can say that in the same vein, V is what? D plus U. Is that okay? v is equals to d plus u. All right. So what we are going to do next now is to make d the subject of the, it's not actually d the subject of the formula. There's something I was supposed to do here, but let me see if it will still follow the same approach. Okay, we need to look for u and v. We need to look for the value of u and v, but we can actually look for the value of u and v from this formula. How? This is equation 1, this is equation 2. Let's do some calculation here. From equation 1, d is equals to what? U plus v, right? So our v is already d plus u. So in place of v, we can put d plus u. I know most of you will not understand this, but just right. So v is equal to d plus u. So at the end of the day, d will be equals to what? This d, we said v is d plus u, which is u plus. Wherever you see this v, put d plus u. So here will be d plus u. So that at the end of the day, what are we looking for? We are looking for u. So we say to find u, u plus u will give us what? 2u plus d, right? Now to look for u, we can take this d to this side. So it becomes d minus d is what? 2u. So that at the end of the day, 2u will be what? D minus d. And then u will be d minus d divided by 2. All right? So that is our u. Now let us look for v. Let us look for v. We already said that v is d plus u. All right? Now, let's rewrite these two things again. The first equation says d is what? U plus v. The second equation says v is d plus u. Now we want to look for v. How do we look for v? It's very easy. Wherever we see u, let's make use of the formula here. So this v will come to this side. So it's going to be d minus v is equals to u. Now what does that mean? Wherever you see u, are you getting it? Put d minus v. So looking at this equation, our v now will be equals to this small letter d plus this d minus v. All right, which is v is equals to what? D plus d minus v. Now at the end of the day, take this v to this side, become v plus v is what? D plus d, which is 2v is what? D plus d. So we can say that v is what? D plus d divided by 2, while u is what? D minus d divided by 2. But we said that the mirror formula says 1 over f is equals to what? 1 over v minus 1 over u. Now, I told you that if you look at this diagram very well, our u is negative u. Why? Because the distance from the lens to the image is in this direction. So we can say that this formula will also be 1 over f is 1 over v minus bracket 1 over minus u. In place of this u, we can put minus u. This one cancel this one and it will give us positive value. So 1 over f is 1 over v plus 1 over u. Now what is our v and what is our u? We can substitute them in now. So 1 over f is 1 over d plus d over 2 plus 1 over d minus d over 2. So 1 over f is, what is the reciprocal? 1 over d plus d over 2. See, it's as what? 2 over d plus d plus, here is 2 over d minus d. All right? So we come to the next slide. You have 1 over f is 2 all over d plus d minus 2 all over d minus d. Now, at the end of the day, you find the LCM of this and this, of course, will still give you the same thing. Alright? Which will be LCM of this and this will be d plus d divided by d minus d. This divided by this will give us d minus d times 2 will be 2 bracket d minus d. Then minus. Then this one divided by this will give us 2 bracket d plus d. Now this will be 1 over f. This multiplied by this will give us 2d minus 2d minus 2d minus 2d. Alright? Exactly. Are you sure I haven't made any mistake here? Are you sure? Let me confirm. Okay, this stuff is actually positive. Why did I use negative here? It's positive. Alright. So, here will be positive. Alright? Then here will be positive. Now, divided by this difference of 2 square. D times d will give us d square. D times this will give us minus d. D times this will give us plus d. D multiplied by this will give us minus d square. These two can cancel out. Alright? So that our 1 over f will be equals to, now in the same vein, these two minus d and plus minus 2d and plus 2d can also cancel out. Alright? When that happens, what are we going to have now? It's now be 2d plus 2d divided by what? D square minus d square. So 1 over f. 2d plus 2d is what? 4d divided by d square minus d square. Now, what is the reciprocal of this? It will be f over 1. That is, f will come up, 1 will come down. This one will go up, this one will come down. So this will give us d square minus d divided by what? 4d. Because once this one come up, this one come down. This one will also come up, this one come down. And do you agree with me that this is the same thing with our slope? So the relationship is that f is equals to d square minus d square divided by 4d. Now, my dear student, there's something I want you to point and I want you to look at here. Do you agree with me that we plotted a graph of what? D square minus d square over 4d. I mean over d, which is our slope. If you look at it, the slope we calculated here was d square minus d square over d. Are you getting it now? So we can now say that our focal length f is what? Is this our slope here. Are you getting it? Our focal length is, or we can multiply both sides by 4. If we multiply both sides by 4, here will be 4f will be equals to, the 4 used to multiply this, we cancel this 4 out. So 4f will be equals to d square minus d square all over d. So how is the focal length related to the gradient? So the focal length is 4 of the focal length is equals to the slope, which is equals to the gradient. So 4 of the focal length is equals to the gradient. Alright? That is what you expected to prove in that case. 4 of the focal length is equals to the gradient. So you write all this here and prove everything you can prove. Alright? Exactly. Now deduce the focal length of the length from your slope. Deduce the focal length. How do you deduce the focal length from the slope? What was the slope? The slope was calculated as 144 centimeter. So you come here and say 4f is equals to the gradient, which is the slope. All right. So 4F is 144 centimeter. Divide both sides by F. This cancel this. Your focal length will be 144 divided by 4, which is 36 centimeters. So this is your slope. Now there is no focal length rather. Now there is no like range of values. Any value you have for this particular practical, just write it the way it is. Don't try and manipulate it and get 36 like what I have here. So that's basically everything for this practical. Quite technical, but it's not something that we cannot do. Thank you very much for your time. We'll see you in the next one. Have a nice day. Bye bye.